Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of multiplying polynomials. This is standard A.10B in the great state of Texas, and we are using item number 23 of the 2025 release STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we simply need to find an equivalent expression. We've got two different binomials here, and we are going to apply the distributive properties. That is something that we've actually been working on, at least the core ideas of it, all the way since third grade, since we've been using breaking apart to multiply two-digit by one-digit numbers. And we've kind of formalized it more in middle school, but we've been using this idea and properties of operations for a long time. So what we have is we have this basic definition, which sometimes doesn't make a whole lot of sense. We get A times the quantity B plus C equals AB plus AC. And all that means is if you have a multiplier on the outside of a quantity being added to another quantity or subtracted to, or some type of operation happening on the inside, you can take this outside multiplier and you can multiply it by both of the inside terms, and you just simply need to maintain that operation. So this A times B becomes right here, and then the A times C becomes right here, and you still have to add. Now, the challenge comes when the outside quantity is itself a binomial, when it's got two different terms. So most of us will remember this FOIL, which works when it's a binomial with a binomial. Doesn't work when it's a binomial with a trinomial or something like that. So it only works when it's a two expression times a two expression. So first, outer, inner, last. So it works when it's a two by two here. So that works here. So we can go ahead and use that. So what that means is we need to basically we need to take each of these and then multiply them by the 3k minus 4. So we need to take the 2k squared and we need to multiply it by both of those. And then we need to treat this as a negative 3m and multiply it by both of those. So we're going to end up with 4. So we're going to take our 2k squared. That's our first. So the first in each is going to be that. And then I'm just going to put a 3k right here. And then our outer, so that's a 2k squared. And I'm going to have a minus 4. So I'm just going to do a plus negative 4 times the 2k squared plus inner is negative 3m and the 3k. So I'll do negative 3m and the 3k. And then we kind of ran out of room, so I'll do it on the front. It doesn't really matter where you put it. The last is going to be negative 4 times negative 3m, because we're going to end up having to combine like terms anyways. And so you can always plus each of these as long as you're keeping those terms on the inside. So now we simply need to simplify and then combine like terms. We're going to have to rearrange them anyway. So negative 4 and negative 3m, that's going to end up being a positive 12m. So 2 times 3 is 6. K squared times k is actually k cubed, or k to the third. So I've got m's and k's. We're going to have to keep track of all that. I've got a negative 4 and a positive 2. So I'm just going to go and put that as a negative 8. And then that k squared doesn't do anything. And then I've got a 3m and a 3k, and I've got a negative 3m. So let's go ahead and make it a minus 9. And I can't combine the m and the k, so I'm going to write both of them, but we typically put them in alphabetical order. Okay, so I can't combine any of these. All I need to do is rearrange them. Well, typically we go by degree. So our largest degree is right there. So we're going to put that first, 6k cubed. Our second largest degree is right there, 8k squared. And since we're working with k's, let's keep anything that's got a k here. We're going to put this 9km. This m goes last. It's got the same degree as the other one, a degree of 1. We'll put that last. So there we go. Our answer is going to be C.